Welcome, everybody. Thanks for joining. Just got a couple of people in the waiting room still coming on in, so we'll give them just a minute and then we'll go ahead and get started. But thanks so much for being with us tonight. Okay. Well, let's go ahead and kick things off. So for those of you who don't know me, my name is Caterina or Cat Rizzoni. I'm an industrial designer at Mammotome, where I design breast biopsy devices and other surgical solutions for the breast area. And I live and work in Cincinnati. And volunteer with the Cincinnati IDSA chapter. And so we're really excited to bring you this event here, which is a collaboration between the IDSA Columbus, Cleveland, and Cincinnati chapters. This is the 5th year in a row that we have done our Blurred Lines event series, which focuses on the fuzzy edges between industrial design and the other fields that we frequently collaborate with. In the past, we've explored the intersection of design and business, UX, even design and your work-life balance. But this year, we're really excited to dive into one of the core relationships that we encounter in our professional careers, which is the intersection of design and engineering. So these are some of the big blurry lines that we encounter every day. So we're really excited to bring you two panels of design and engineering professionals who are going to talk to you first about some of the skills that you need to cultivate a great career collaborating with engineers, and then also some of the communication skills that can help take you to the next level. And then we'll end with a Q&A. So throughout the event, please feel free to drop any questions that you have in the chat. We'll keep track of those and circle back to them during the Q&A at the end. So just want to do some quick housekeeping as well. Please stay muted throughout this event. This is a sort of meeting format during the Q&A. If you'd like to ask your questions in person, you can turn your camera on. But while the speakers are talking, we'll just ask you to stay muted. And then also, just so everyone is aware, we are recording this event and we'll be posting it to YouTube afterwards. We will also be sharing out a resource that we're going to create using the insights that our speakers put together during this event, as well as some other resources that designers can use in their careers. So without any further ado, I'm really excited to invite up Dwight. He is also in the IDSA Cincinnati chapter, and I will let him introduce himself and then talk us through our first panel.
Hi, my name is Dwight. I'm an industrial designer based in Cincinnati with a background in consumer goods marketing. Thanks so much for joining us today as we dive in between the intersection between design and engineering. Our first panel focuses on the skills you'll need as an industrial designer to grow your career and collaborate with more effectively with engineering teams. We're going to walk through the tools, resources that help build technical fluency and exploring looking beyond design and what beyond design school can look like. I'd like to welcome our panelists to the stage, John, Josh, Kristi, and Scott.
Hi, how are you doing?
And Henry.
Hello.
Hi, everybody. My name is Josh Haldeman. I'll be your host for this session. I'm a volunteer with the IDSA Cincinnati chapter. I've been doing this since 2013. I'm also the director of the Innovation Lab at Seven Hills School and an adjunct professor at DAP. Today, we have joining us Scott Urban and Kristi Bartlett to talk about building your toolbox of engineering skills. Scott is a senior product designer at the Metcalf Group, and Kristi is an assistant professor of product design at the University of Kentucky. If you have any questions during the session, please drop them in the chat and we will get a chance to answer them during the Q&A at the end. Scott, Kristi, thank you so much for joining us. If you'd like to briefly introduce yourselves, that would be fantastic. Kristi, do you want to start us off?
Sure. As Josh said, my name is Kristi. I am an assistant professor of product design at University of Kentucky. This will be my 3rd year there this coming year. But I also have a background kind of mixed between engineering and design, which is probably why I was invited to the panel. So originally, as an undergraduate student, I studied civil engineering. I finished that degree. I wasn't excited about it. A few years later, I decided I wanted to go into medical product development. And I was choosing between doing a master's in biomedical engineering and industrial design. And I chose industrial design because I saw just the differences between what kind of education engineers get and industrial designers, in terms of the human-centered focus and the usability focus. And that's what I was looking for. So I did that major as my master's, and then I did work in medical product development in a role that was kind of a mix between industrial design and engineering, since I was working in a startup and you kind of had to wear a lot of hats. So that's me.
That's fantastic. Thank you so much for joining us, Kristi. Scott, do you want to take a minute and introduce yourself?
Sure. Yeah. So I'm Scott Urban, and like you said, I work at the Metcalf Group, which is a product design, it's an industrial design and engineering company. And in my day-to-day there, I really go back and forth between industrial design and mechanical engineering there. I got a bachelor's in industrial design, but I did minor in mechanical engineering technology, and really I was, like I think a lot of people, deciding between design and engineering, and I was happy to find a role that I really could do both. And even though I only got a minor, I've over the years done a lot of learning on the job, from just, what we learned in school to doing FEA, and so, it's really a big mix of design and engineering. And, the blurred lines title is appropriate, I feel like, for my day-to-day work, where it's like, half the time I would have trouble saying whether I'm doing industrial design or engineering. I'm just, making products.
I had a student come to me one time and tell me that he wanted to design roller coasters. And I said, "Oh, great. Well, what part?" He says, "All of it." I said, "Okay, 5 degrees, I think I counted up at but Scott, you sound like you're well on your way. And Kristi, you as well. That brings us to our first question, which is, I'd like you both to take a minute, consider this. What does it mean to have technical fluency as an industrial designer? Does it intersect with manufacturability? And, yeah.
Sorry. I guess so. I was thinking about this a bit, and I think there's different levels of technical fluency. Like, you can be someone who can, essentially take on, I'll say a minor engineering role and really do some lightweight engineering on a project, and take it all the way to manufacture. Maybe you're not a full engineer, but just about there. But for, I think, most industrial designers, you're not trying to be as deep as an engineer. You just, you need to understand the general principles. You don't need to know how to design a circuit, but you do need to know that if you need more power in the circuit, it's going to have to get bigger, and you're going to have to cool it. And you don't need to know how to calculate the deflection of an I-beam or know what moment inertia is or something. But you need to know that if you have a thing, that a piece of invisible cardboard, it's easy to bend this way, and then hard to bend this way. And if you bend it too far here, it's going to, buckle a little bit. So maybe you need to have a little thing down here. And if you just understand those principles, you can kind of figure out, I need ribs on my product. And then you need some manufacturing knowledge to know that, I might have sink marks on the other side of the product. And so now I can bring in my design skills to figure out how to make those ribs look nice. Do I need to texture it to, hide those sink marks? Can I put them in a certain direction that looks okay? So I guess that's what I think of when I think of technical fluency, is you're familiar with all these different areas, not necessarily, being able to go as deep as the engineer.
Yeah, kind of a jack of all trades, master of none, something along those lines.
Yeah.
Kristi, what are your thoughts?
Well, something I was thinking about too when asked this question is, on the one hand, I think we can talk about it for traditional industrial design for physical products. Obviously, manufacturability and understanding that is important. But increasingly, a lot of products are going to be either smart products with digital components, or a lot of industrial design students might find themselves working on purely software products in the future. So I think those are also areas that students or anyone who wants to expand their technical knowledge could learn more about in like software engineering or understanding kind of how devices communicate. So I think manufacturing is definitely part of it, but I wouldn't say that's like the end all be all of the technical knowledge that designers might want to know.
Yeah, you both mentioned a little bit about like kind of learning on the job, but do you have any specific resources or ideas about like where to go to get some of those skills or to upskill in areas where you feel like you need to improve?
I think there's so many different answers, kind of depending on what you're trying to learn and depending on what stage you're in. So if someone was in school and they have this dream of like, oh, I really need to know mechanical engineering, then I'm sure they can take some electives from the mechanical engineering department at their school or take a community college course in the summer or something. If you're still a student, like it's easy, low-hanging fruit to take classes from other disciplines. And I think you would just need to read the course catalog, right, of your university to find out what's out there. But then also there's increasingly online resources. Like if you want to learn software engineering, you can go on codeacademy.com and start learning it for free. Or there's a million similar websites that have like a progressive learning that's very accessible. If you want to learn circuit stuff, you can order on Amazon like the Arduino starter kit for maybe $80 or something like that. And there's a book of little lessons that are super accessible and super easy. So I think there's a lot of different answers depending on what somebody was looking for.
Yeah.
Yeah. Yeah. And I think, it's a lot of, sometimes, I think the specific courses you're talking about, and, if you are a student, I think I've been encouraged to hear more about different programs collaborating with other departments. So if you talk to your professors, they might know of like, oh, hey, we've got this program going, or I know some professors. So I think, ask around and you'll probably be able to find it as long as, your university has ties to another one. But, in addition to more focused courses, if you're trying to look up just like, I don't know, it's like, okay, I know my product is injection molded. There's so many injection molded guides, mostly by companies trying to sell you something, but they're at least halfway decent that'll, teach you about the main things you need to know for injection molding. And then I'd also say, if you've got other people around, ask a lot of questions and, be specific with your questions and ask for details. Like, if there's for some reason 5 circuit boards in this product, like ask why, ask what they are doing so you can get a better sense of what's happening. And, I'm, reminded a bit of like the 5 whys idea, but maybe don't go that far or you'll annoy some people, but like ask a couple of whys, like, you say it can't pop out of the mold. Why? Oh, it's an undercut. Okay. What's an undercut? And then like, okay, what are alternatives? And I think, that's, more of, how I've, learned little bits over the years is just, asking a lot of questions from your colleagues.
Yeah, I think that's a great strategy. My camera's not going to blank this out, but yeah, I've got the Proto Labs products like always within arm reach somewhere because they're so convenient, helping me to understand details, issues, challenges, problems when they come up, and sometimes how to address them. I think that they do a really phenomenal job, especially when it comes to injection molding. Okay, moving on. Maria sent this question into us. She says that as a designer with little technical experience, what advice do you have to initially break into that space? Not clear which space specifically within the technical experience, but you guys can choose which one you want to focus on. Injection molding or anything else.
Yeah, I mean, I think I think if you really want to like, I don't know, break in is a an interesting term. If you want to like be actually doing like the more technical things for a living, I think having some kind of formal education or at least taking some formal classes makes sense. But I think to just kind of start doing it as an industrial designer, I think is just just show up and start trying to do it. Like start asking the questions, start showing up for the meetings, or asking to be part of the meetings, the design reviews, and the discussions with the manufacturer and with the electrical engineers. And so just kind of just start, and it's not even like fake it till you make it. Just be, because nobody's expecting you to be this technical expert, but just show up and try to absorb as much as you can. Like nobody's gonna fault you for asking like why your design got rejected and totally changed for some technical reasons. Nobody's gonna think poorly for you. They'll really think positively, I think.
Yeah, I find that most people are really proud of the knowledge that they have, and are most likely, most often, frequently willing to share that with others, especially folks that are interested and express a desire to have a better understanding of something. I've had that experience a lot in my career, talking with manufacturing experts and mechanical engineers and other folks, to get details and information about like the whys and the hows, and they I also have found that it seems like the strategies for getting some alignment so that design goals don't go out the window with engineering requirements. So, or vice versa. Like, we want to make sure everybody's happy. When we do that, we get much better results. So yeah. Kristi, what are your thoughts on that, about breaking into technical experience and best avenues to get into that space?
Yeah, sure. I think I'll answer, since we don't know the context that this person is asking from. Let's pretend the person doesn't have an industrial design job right now where they can just walk down the hall and start, poking their head in. I think something that somebody could do is try to do some personal projects that lean more in that direction, and then try to add those projects into your portfolio. So rather than having a portfolio that kind of only shows rendering and sketching, you want to maybe do some hands-on prototyping and experiment with like maybe casting and mold making. If you're trying to deepen your knowledge in injection molding, you could start there, and show some more hands-on explorations that you will learn through the process of doing that. And then you would also be able to talk about that more in an interview, or present it in your portfolio. So I think I would just start doing it. Like even if you're going to pursue education in a formal setting, like education scholarship shows that actually learning by doing something is still the most effective way, even if you're in a class or whether you're at home doing it yourself. So I would try to get your hands dirty and do something, even if it's starting basic, to try to teach yourself and advance your skills a little bit that way.
That's great. Yeah, that's good advice. Okay, our next question is, which skills are the most important to have as an industrial designer hoping to see your design vision brought to life?
So I think like the number one and number two for me are the manufacturing methods that you're going to be designing for. If you're designing a physical product, at least, you need to know how it's made. And there's lots of different methods out there. So just whatever you're currently focused on, just know the manufacturing methods at least reasonably well. But then two is just like the basic principles of whatever the product you're designing for is, like whether it's like a water sprinkler or an like IoT camera or something, just like knowing how, like just the basic principles of how it works, I think goes a long way towards like fitting, the form and function together. If you don't know the function, you can't really design the form to fit it. And it'll also help your, the user experience design to know, help the user, have a better understanding of how it works. So that's like my number one and number two. But any skills that allow you to perform prototype faster are helpful, especially if like you'd have to wait on the expertise of others. So like knowing some Arduino to make a quick prototype of an electronic circuit is helpful. Basic understanding of physics like remind yourself of high school physics a little bit. Watch some YouTube videos, and like technical drawings is another thing to know, just like so you can kind of speak the language of the engineers, even if you're not creating them yourselves.
Yeah, that's great. Good advice. Kristi, what are your thoughts?
Oh yeah. To build off of that, like it, the question is really broad, but if assuming you have this design vision, it's a certain thing. So can you become an expert in that area, even maybe by buying a bunch of cheap products from that area and taking them apart and really studying what's going on in those? And that's something that I did for a medical device I was working on. It was similar to a bathroom scale. We had maybe like 4 or 5 different cheap bathroom scales that we had completely taken apart and could completely understand, like, oh my gosh, here are all the different possibilities of how the plastics would come together, how it would attach to the glass, how the feet attach to the load cells, what styles of load cells can we buy? Like, just from doing that, which costs maybe, $150 to buy a bunch of scales, you can learn so much about that specific thing that you're trying to build. So I think I would do that if you have a specific vision of a product that you want, really trying to become an expert in the different possibilities for how those products are made.
Great. Yep. A lifelong destroyer of things. Always so sometimes they come back together, but not always. Yeah. Okay. Some good insights so far. Our next question is, when learning technical concepts outside of your discipline, what has worked better, formal training, on-the-job learning, or something else?
I guess, for mostly it's been, on the job learning, I guess. But I did have some formal classes as a foundation. So it's not like I was starting from zero. So I do think, and I think, just, being in a consultant role, we're always having to learn for every project. So I do always do some research, either, looking at, online things or books or whatever, but it hasn't been as much formal as I've gone along, but I did have, formal foundation, I'll say.
Yeah, and I think one of the biggest values of the formal training is the accountability, I would say. So if you're taking a class, you're forced essentially to do the assignments, and like you're going to do it because you signed up for this class and maybe you paid for it, or you're getting a grade, or you have that accountability to force you to keep going. So I think that's the value of formal training. You still need to learn by actually doing it, but some people are less motivated to just do it by themselves. So I think having accountability somehow will help, but either way, like whether you do it yourself or take a formal route, both can be valuable for sure.
Great. All right. Good stuff. Our next one, Hayden and Tiffany actually had similar questions for a junior designer or design student, especially those who went to schools without a strong engineering focus. What resources, software, or skills would you recommend to build technical fluency and better prepare for working with engineers in a professional setting? I'm going to start with this one since we have you're seing a lot of students, so I'm wondering specifically about what you guys are teaching, like, and why, and whether or not that interfaces with the engineering programs.
Well, one of the things that we do in our program is we do have one studio, which I teach, which is a collaboration with an engineering, like, capstone design project. So that gives the students really hands-on experience of what it's like to work with engineers. Obviously, engineering students and engineering professionals are not the same. But I've noticed some of my students, like, once they're in that, they realize engineers don't know everything either. And they also need to look things up, especially engineering students, but anyone. Nobody has everything they learned in engineering school memorized. So everybody is going to look things up, refresh their memory, dive in deeper on something. And design students can do that too. So like one of my students was helping with a boat design. His teammates asked him to do the propellers, and he was like, I don't know. What's the principles behind designing propellers? How do they thrust? And those are different things that he could look up and also apply to the design. So that's something that I've seen just as I've been coaching the students in these projects, is that anybody can look things up, especially now, everything's on the internet. You can watch a YouTube video, you can read a textbook if you want to, but there's always ways to get the information and try to apply it to your design, even if you didn't take a formal class about like boat design, for example.
I'm curious. You've mentioned looking stuff up online a little bit already, and there's a lot of information out there, of course, and some of it's fantastic, others not so much. Where or do you have any specific recommendations in terms of like TikToks or YouTubers or whatever people that you like and follow, or something along those lines?
I think because of the information that my students are usually looking for is so specific that there's not like one channel that they could go to find that out. There certainly are, I'm sure there are some great channels that have like general technical learning or general engineering learning. The one thing I would avoid, and because I have had students led astray, is just asking everything to ChatGPT, because ChatGPT has given my students like the wrong equation model to follow for something that they were trying to model. And just because ChatGPT doesn't have this level of understanding that it sometimes appears to on the surface. So I would, if your website that you're looking at ends in edu, that might be good. If it ends in AI or something, that might be bad, right? So like use your judgment about where you're getting the information, but there's certainly tons of more scholarly resources out there that can be reliable.
And I think, if you're getting the same information from multiple sources is a good way to check it. So even like, YouTube, even if I'm just like learning software, it's like, I'm looking at videos from multiple people, and, like you, it's like I don't really have one specific one that I'm following. There is one that has like a bunch of mechanisms. I think it's like Fang. I'll put that in the document. So yeah, it's just like a lot of the videos and things. And you had asked in your question, if the school didn't have much of an engineering focus. Like I know there are some art schools that aren't affiliated with like an engineering department, and I think Kristi's mention of product teardowns was a really good one, and doing them yourself, and even if I feel like I come across them occasionally. I tried to look up some on YouTube, and unfortunately it's now become a term that software developers use, so it's like taking over the search feed, but you can find them eventually, because I've seen some good ones. Where people are taking apart a project and then, commenting on how it might work and, maybe why they did these things. And I think those are really good ways to learn, but also do them yourself too, is really important. And, when you're on the job, if you don't have engineers like next door to talk to, you probably have somebody who's making it. And so like I said, talk to the manufacturers. They know how to make the thing better than the engineers. So talk to them, as another good resource for learning how to do things.
Yeah, those are some great insights. David Carroll just posted a message in here asking, how is AI being used in the design process, and where might it be used in the near future? That's veering a little bit away from the focus of our session here. But I think it's an impossible subject to avoid. AI is everywhere right now, and for good reason. There's a lot of things that it does very well, and there's a lot of things that people feel a lot of frustration or anxiety or concern about. Kristi, to your point about giving students the wrong information, while completely justifying it being the right information, it is a big trap that a lot of folks fall into. But yeah, I'd be curious to know, Scott, like, are you guys using AI right now? What and how do you leverage it? What do you use it for? How does it blend in with the design process?
I mean, we've used it some, I'll say more on the design versus the engineering side. I mean, not a lot, but we have used it a little bit in, creating concepts. But, and, it's like when I'm searching for something, I will read the, like AI summary, but I think I definitely don't trust it enough to use it as like the definitive answer on anything. It can help me, lead me to a more concrete resource. But I think I'm just, skeptical of it providing, answers right now. It's not going to create an engineered, like if I say, I don't know, drew a picture and said, make this more substantial, like it's not going to know how to place the, the ribs and things, or, thicken, the wall thicknesses, or, know how to manage heat or something. Like it doesn't really, I guess, solve the engineering problem right now. So yeah, I don't really have a solution for using it for engineering
Cool. Yeah.
right now. I mean, I'm sure there are people are, but we aren't in that capacity.
Okay. Kristi,
Yeah, no, I agree. And I think it actually, in a way, relates to the question that Tiffany just asked in the chat she was asking how important is it to be fluent in SolidWorks versus Rhino if you're communicating with engineers and manufacturers. My understanding, I could be wrong, but I don't think most manufacturers are going to be using Rhino. I think that's used more in architecture and more in like conceptual development versus engineering development. And I would say AI right now in the design process seems to be most useful in like this kind of conceptual development phase, and doing artistic ideas or conveying some emotion behind the design with some cool AI artwork is definitely a big part of the design process, and especially valuable for like marketing your idea. But for actually refining and manufacturing an idea, things like SolidWorks, which does not have any AI integrations, at least right now, that are making a big difference, is really important. And so that kind of technical knowledge so far hasn't really been, taken away by AI. Obviously people are working on that, and people in engineering design space are certainly thinking about how to integrate AI into that engineering design process. But I wouldn't say it's currently something that's like a must-have skill.
Yeah, and I think there are some, I'll say, advanced engineering things that people are doing of something that's been done for a long. Can't think of the word. It's not really AI. I can't think of the word. Where the surface optimization. Why can't I think of the word? But there's some pretty advanced software on like the really far engineering side, but it hasn't made it into SolidWorks or Creo that I know of. I mean, it's still if you get a 3D model from an AI software, it is absolutely useless for manufacturing. You're going to have to remodel it anyway, at least at this point. Generative design. That's more for creating concepts, and still not quite the right word what I'm thinking of for.
A bunch of people are jumping in the chat saying generative design is the word we're looking for. We're going to come back to the questions that are coming in via the chat during the Q&A portion of this, but I want to get through the questions that came in advance here. Shifting there, one of our next questions was, how early should designers get involved in technical conversations, and what is the best way to approach them without overstepping? Scott, what are your thoughts there?
So I think earlier is better. I mean, unless it's like some really fundamental research that's like way before like an actual product for a consumer is conceptualized. Earlier is better because it's when like the basic principles are being discussed, and once that has been generally nailed down, there is a lot of work for refinement and optimizing the design that's going to go on in the engineering department. And you really don't want to come in like after they've done most of that and propose some new design direction, because nobody's going to have the appetite to redo that work. So it's just in the early phases where just is it going to be, square or rectangle, or circle, like, the basic, where, the basic concepts are being discussed. It's really where you want to start discussing it. And, I don't think I'm sure there is a way to overstep, but, you as long as you have the attitude of, approaching it with curiosity and knowing that, you're not trying to do their job for them. It is good to be able to create, a nice clean model that they can just use instead of having to recreate it. So in that way, okay, there's like some overlap of tasks, but you're not trying to tell the engineer what to do. You're just trying to like be part of the conversation, I guess I'll say. It would be maybe the approach I'd take, and maybe find a friendly engineer versus a grumpy one.
Yeah, that's a good point.
Yeah, I think in my experience, there was a time when like my colleagues and I were working with some engineering consultants, and we found that when one of my colleagues would speak with them, I think the way he approached them always kind of made them get really defensive. But when I approached them, I think I did just what Scott said. Like I always tried to be like, oh, I just really want to understand this. Like, let's say we thought that they were telling us something that was wrong. We did not ever say that. We were just like, well, I really want to understand why this is. Like, I don't really know about this. Can you explain this to me? And then sometimes we would realize like, oh, they were right, we were wrong. But when we came at them with like just this really sincere curiosity, we want to understand this better because we care about this project and we want to learn more about your area, that always went well. And it didn't turn into this like defensive or like, trying to seem like more than the other person when we did it that way.
Yeah, I like that that thought about approaching it that way. It can frequently become contentious conversations between designers and engineers, just simply because we're both trying to solve the same problem. We've just got different focuses. And I've always thought of the industrial designers as the advocate for the consumer in the design process, and the engineer being the advocate for the manufacturers, and making sure that the concepts or the thoughts can be made. But it's two halves of a whole. It's not one versus the other. So anytime those contentious kinds of things come up, that's usually a bad result. Okay, next question comes from Teo, who asks, how can I better understand the constraints and opportunities of manufacturing methods, electronics, and materials early in the design process so I can design with greater technical empathy? How can I better understand the underlying engineering principles like circuitry, energy efficiency, and material behavior so I can design products that are both elegant and technically feasible from the start? Great question. Kristi, what are your thoughts about this? Especially interested in hearing your thoughts from the academic perspective, like when you have to teach students how to take into account like all of the different things that go into getting a product made. What do you give them advice on? How do you approach it?
Yeah, I think this person, like, their question is really getting at this overwhelming, like, oh my gosh, I have to understand everything at once, like circuitry and energy efficiency and material behavior. Like, that's so much to bite off in one chunk, right? So I think, again, it always goes back to learn by doing. And I think one of the big strengths of design education is that it's always like project based, right? You have a project that you're working on in studio. Can you figure out for your specific project, what are the most important things that you should worry about, or like prioritize one thing first? So if you're doing some interactive project and you maybe want to incorporate Arduino in that project, that would be a great way to start learning something about circuitry. You're not going to become an expert in circuitry during one project, but you could at least understand like a lot more than you did before if you implemented that. And if you want to learn about material behavior, there's not like some easy kit that you can buy on Amazon to learn about that. You're going to have to probably read a textbook or look up some resources, about material science, which is much different. And so I think a designer, like you don't have to become a deep expert in all these different areas. Even an engineer wouldn't be. That's why there's different disciplines of engineering. But if you can focus it in on your project and think about, okay, for your project, your cup holder that you're designing, like how are you going to manufacture that exact thing? And research just the manufacturing methods that apply to your project. And then on your next project, you can learn about something else, right? But I would try to hone in and figure out how can you make your specific thing as realistic as you can by learning the things that apply to that exact project at that time.
That's great. Good insights, Kristi. Scott, how about you?
Yeah, I mean, that was partly gonna be, my answer of like, at the start of every project, there's always, a research phase, and it's, if I don't understand how something is working, I'm Googling, how does this work? Sometimes, it is, looking in a textbook, and, the teardowns of competitors, I mean, competitors in like, if it's a very established product area, then, like you said, like bathroom scales, if you're designing another bathroom scale, well, buy 5 of them and, tear them down and understand how they work. And now, kind of the universe of options. If you're trying to be really innovative, maybe you start looking at some kind of tangential products, like, I don't know what it would be for bathroom scales, but, just something that's, kind of similar or doing a similar function, and just understanding what they are as really, for the fundamentals. So you have an idea. So you're not like, 7 weeks into the project realizing you forgot to make room for this really important component. That's, I think a big part of it. And like Kristi said, learning by doing, I think is really important. Because especially in things like circuitry, like there is one course that I'll put in the resource document that I haven't done, but it seems like pretty good. And it's for learning electronics. And there's really an emphasis on learning by doing, and it's like, well, you're not going to become an engineer. You don't necessarily need to know all the principles behind, how a circuit works, but it's actually not that hard to hook up some resistors and capacitors and, make a light blink. And that's like the level that you need to be at, to be able to, to design a thing. And I guess I would say, back to, asking questions. If you're starting on a project and there are like engineers who have been working on that for a while, like you're starting a new company, like, buy one of them lunch and say, hey, can you just sit me down and just tell me about how these things work, for an hour or something, just to, get some fundamental understanding. But like Kristi said, it's really project by project, because like we are the jack of all trades, and you can be a designer who designs sneakers one year and then medical devices the next year. And so the only way is to be this jack of all trades, is learning project by project.
I love it. Yeah, and I think that's the overarching theme of most of this conversation is lifelong learning is the answer. Mm-hmm. Don't ever stop learning. There's so much information out there that you could spend every second of every day learning something new and never run out of things to uncover. It can be overwhelming sometimes, but it can also be a lot of fun. So yeah. Our next question, and we've got just about a minute left here, so this is probably going to be our last one. What advice would you give to a junior designer who wants to become more technically fluent without losing sight of the user experience? Kristi, do you want to take this one?
Yeah. When I read that question, I thought, I don't think that someone who's trained in design will lose sight of the user experience. Like if that's your training, that's kind of what design is all about. So engineering is usually not focused on the user experience, or at least engineering education. That's not the focus. The focus is on like math and physics principles and, equations that demonstrate those. So I think becoming more technically fluent, I don't think you need to worry that you're going to also lose sight of the user experience. Like it's not like a zero-sum game or something. So I would encourage someone to be totally willing to dive into learning about technical things without this fear that that automatically means that they're going to lose sight of user experience or like stop being able to make a product look beautiful or something. Like that would only happen if you totally disregard that as a result of gaining technical fluency, which it doesn't sound like somebody would do.
I remember working for a manufacturer several years ago and feeling like, what, you want me to use the left side of my brain? What the hell? This is ridiculous.
Yeah.
But yeah.
And I guess I would just say quick, like, I think, understanding the engineering will can help get your user experience insights to the final product and make sure that they don't get left on the cutting room floor, as I think is maybe the reason to learn that. And also, like, sometimes you just, you need to wear different hats or, think in different modes. Like, it's just like, I don't know, it's just like sometimes it's like on a product, it's like I have to just like mentally say, like, I'm switching into like creative mode or thinking of switching into like I need to do the engineering analysis mode. So like you can just like have it all in your head and just, just put a sticky note up, like like think about user experience every day and just like do it.
Love it. Yeah, it's a great idea. I'm gonna do it right now. Don't forget the users. Kristi and Scott, thank you so much for participating in our panel discussion here. I'm going to hand the reins back over to Dwight, who is going to introduce our second panel. So, Dwight, you want to jump in and take over?
Am I visible at all? I don't know if my camera's not working. Oh gosh, sorry. Either way. Thank you, Kristi, Scott, and Josh. While the first panel focused more on individual skill building, the second panel is focused more on successful communication, or more on the communication aspect between design and engineering. One of the most important and challenging collaborations when it comes to product development. This session, this panel is designed to help build confidence when collaborating directly with engineers and helping to communicate your design vision more effectively and successfully. We'll be diving into tips and tools for bridging those communication gaps and how designers and engineers can work together to make better products together. Carly, Kat, Grant, Adam, and Ian, please join us on stage.
Hi, everyone. I'm Carly Giles. I'm a volunteer with the Columbus IDSA chapter, and I'm also an industrial designer at Design Central. Forgive me if I sound a little bit stuffy. I am feeling a bit under the weather, but I am still very excited to help facilitate the conversation for this section of the event tonight. This is where we will be discussing how we as designers can better communicate and collaborate across the aisle with our fellow engineers. So tonight we have Caterina Rizzoni, Grant Cothrel, Adam Ruggles, and Ian Rawdon. Kat's currently working as an industrial designer at Mamatome, but she used to collaborate with Grant at Kaleidoscope, where he works as a staff design engineer. And then Adam and Ian are another design engineering duo from Design Central, where Adam currently works as an industrial designer. And then Ian used to collaborate with Adam at Design Central, but now works as an engineer at OSU's Center for Design and Manufacturing Excellence. Once again, for the audience, if you have any questions, feel free to leave them in the chat and we'll try to answer them at the Q&A after the end of this panel. Kat, Grant, Ian, Adam, thank you so much for joining and volunteering your time to be a part of the conversation. We could get started with some brief introductions.
Well, I already kind of gave a high-level introduction. So like I said, I work at a company called Mamatome. So this is a company that designs, engineers, and manufactures medical devices that are used in like an outpatient or sometimes a hospital setting. So I used to work with Grant on the team at Kaleidoscope, which had a design department and an engineering department. But these days, I am actually on an engineering team. I'm also the only industrial designer in the company. So I do a whole lot of collaboration across the aisle. So I have to make a pretty good case for the industrial design side of things. But I enjoyed collaborating with the engineers at Kaleidoscope so much. I just said, let's have some more of that. So I guess I'll tag it over to Grant, who was one of my delightful collaborators at Kaleidoscope and a really great partner in design and engineering.
Thanks, Kat. Yeah, so my name is Grant Cothrel. I'm a design engineer at Kaleidoscope, like Kat said. I actually studied chemical engineering, and then during college got interested in medical device design, did some internships with Kaleidoscope. And so I've sort of had to learn on the job a lot of mechanical and biomedical engineering skills, but have that, engineering background with my degree. So yeah, I'm excited. Thanks. Do you want to go ahead, Ian?
Yeah, hi guys. My name's Ian Rawdon, and I currently work for the Center for Design and Manufacturing Excellence at The Ohio State University. Work there currently as a lead medical device design engineer. We got several divisions within CDME, but I work for the medical division there. We kind of have two different pillars there of working with point of care manufacturing at the Wexner and James Hospital at the university, where we help physicians with surgical guides and a variety of different simulations and such like that. And then we also have the medical device design squad that I predominantly work within. So we get to work directly with the physicians there at the university when they have some new IP, some new ideas, and we get to prototype and design and even fabricate and even transfer to manufacturing some of their different med device design ideas. But also, one of the big collaboratives about CDME is, we're about workforce development. We're about mentorship. We get to hire all of the great students that are there at the university, engineers and industrial designers alike. It seems like I've had probably the most passed with industrial designers there, so I tend to get all of the students, I guess. So hopefully I get to voice what you guys do as best as I can as an engineer. But it's a really great mentorship opportunity. I know we have a lot of members here from the Cincinnati area. The co-op program is such a big thing there at Cincinnati, and getting that development opportunity while you're in class is such a huge pivot. And Ohio State kind of lacks in that, and that's where CDME kind of gets to bridge the gap a little bit. So thanks again, and yeah, had a wonderful time over at Design Central before here. Love the company, and just glad to see everyone's faces again.
Adam, do you want to introduce?
All right. Yeah, and I'll go ahead. Yep. As it was mentioned, Adam Ruggles. I'm an industrial designer at Design Central. And then also I take on the role of project manager. I've been Design Central for about 10 years. And then I've also worked for Rawdon in Columbus. And there I was an exhibit designer, working, to develop children's museums, science centers, um, uh, and other institutions. And then prior to that, I was in Chicago for 7 years at a few different consultancies there. So during my career, I've primarily been in design development, and like Design Central, I've the teams comprise of designers with backgrounds in fashion and graphic and UI UX, and then I've always worked with engineering teams of mechanical, electrical, software, as well as research strategists. And then in the case of Roto, I mean, the team was even bigger. We got into motion graphic designers and fabrication and production, and yeah. So then prior to that, I'm a graduate of the University of Cincinnati. I'd say now in my career, similar to what Scott mentioned, even though my background is industrial design, I'm starting to blur the lines a little bit with engineering. I wouldn't say I'm an engineer, but like we said, project by project, you just gain more and more understanding. And so I have a few projects I've done, and now I find myself, taking uh, a project further, if it makes sense for design, as we work through engineering. And then there's back and forth, which, we'll discuss here more. So yeah, looking forward to it.
All right, so getting into the questions, this first question is tailored more towards the designers, but it's what is your goal as a designer when communicating with engineers or as an engineer? Well, okay, yeah. So what is your goal as a designer when commuting with engineers or as an engineer when commuting with designers?
I think someone on the previous panel described it really well. It was like to keep all of your user centered delights, all of the experiential stuff and the goal of your design to like get that to actually get manufactured, to have the vision, your design vision basically become a reality. And so I feel like that's kind of like if I can position it the most manufacturable, feasible solution, cost friendly, try to consider all that stuff up front, then hopefully I get nothing but thumbs up along the way. I feel like that's my goal.
Can you tell me that question one more time, Carly? Just want to make
Sorry.
sure.
What is your goal as a designer when communicating with engineers, and then vice versa? Or as an engineer, what is your goal when communicating with designers?
Yeah, so I mean it's maintaining design intent, so um you've designed a product or you've designed a user experience, and so then, as we're working for in an injection molded product, for instance, right? As we're considering part breakup and the limitations of maybe where we could place buttons or the screen size, right? Like hopefully you're considering that early on. But right, different considerations will come into place from cost. You start those conversations with manufacturing, and so the compromises will be made. But if you have the vision for what the user experience is, right, you can um, help maintain design intent through that process.
And then do we want to hear from one of the engineers?
Yeah,
Um,
sure.
go
Go
ahead,
for it,
Grant.
Ian. Classic. I'll go
Yep.
for it. So I think as an engineer, I'm always keeping an eye to my requirements. Like, what does the product need to do? And I want to make sure that it can do that. I think when I'm talking with a designer, I'm trying to communicate my ideas or the product's design as clearly as I can. There might be technical aspects that are difficult to communicate. So it's, my job to communicate that clearly. And if I'm not, answer questions about it. Um, but yeah, really, my goal is to make sure that at the end of the day, this thing functions. And there's going to be compromises along the way. But yeah, I think that's the main goal.
Yeah, I think one of the, just along like what Grant was saying there, that's a massive goal. One of the last people on the panel mentioned, that we all have different stakeholders that we're appealing to, the industrial designer champions, the user. But really, we all have multiple stakeholders, right? We have the company that we're working for, we have the manufacturer, we have the user, we have just so many people that are involved in the process. And, if you understand where your, skill set is and where your role really is, you could both be managing both and making sure that there's a good blend and a combination. And, industrial designers are often put, right on kind of a silver platter so early on in the conceptualization phase because that's what they're best at. And, one of my bigger concerns that I have for industrial designers is to put a concept in front of someone's face and, promise that something is doable. But, maybe we got to kind of check on reality and make sure that everything looks good there. So, just like I want to have an industrial designer have my back and make sure that we're, keeping the user at prime focus. I also want to make sure that they are presenting something that's very feasible. I think we've seen more than enough times when you have like this amazing concept car that comes out, we're like, oh my gosh, that's incredible. And then you see like 3 years later when the actual car comes out, you go, that looks nothing like it. What are you talking about there? It's hopefully my job that I'm able to keep that, idea that they presented early on, alive as long as I can.
Mm-hmm. Awesome. So with that, when you're collaborating, what do you think is the most common communication breakdown you've experienced between design and engineering teams? And like, how did you address this?
I feel like for this one, I feel like teams get into trouble if they work too long separately and there's not enough like conversation or touch base. Because I think that that's when, like, you talk about the like concept cars, like industrial designers can get carried away, right? I mean, like, we want to make really cool stuff and we're going to push the limits of what's possible. and we're going to probably assume more things are possible than actually are. So I think like, if an industrial design team works on something for a really long time without consulting with an engineering team or collaborating with them at some point, preferably integrated throughout, but like, if you have to bounce it back and forth, I feel like that's, you get kind of end up kind of far apart, and then it can be really hard to like, you end up hacking the design to fit into the constraints and the requirements instead of just designing to the constraints and requirements and having an elegant solution from the start.
Yeah, I like that. I think often it's budget constraints that keep a team small in the beginning, right? But I've seen time and again like involving engineering in design conceptual phase early. I mean, just to have their eyes on what you're considering and sort of um, might see potential right down the road considerations. Um, so, I mean, ideally, you have engineering involved in maybe even what would usually be a a brainstorm of just designers, right? See if you can get an engineer in the room who is going to, bring a different perspective and might be considering different things. Um, and then the same on the other end, right? Like if never, I think we're going to talk about a handoff later, but it's like almost like there never really is that handoff in the sense that like design never goes away and engineering never goes away. It's like they're represented in some way and ideally by, two members sort of championing that at least, right? If not several members.
Yeah, I'll echo that. I was in a brainstorm just the other day. It was mostly designers and a couple engineers, and one of the engineers has an electrical background and totally thought about the problem in a different way. So it could potentially, redirect the entire project. So conversations like that are super important early on. I think the other communication breakdown potential is just who's doing what. There is a lot of overlap in responsibilities, or there can be, between engineers and designers. And so just being explicit about who's going to drive what aspect of the design. If there's an internal mechanism, maybe it's my job to prototype that at first and drive that. If there's a case or a shell, maybe the designer takes that on. But just being, collaborative and clear in who's doing what so that you don't step on each other's toes as much.
Yeah, and kind of, touching on what Caterina was saying earlier too, I think getting siloed is often a really big thing. At Design Central is such a open area with all these desks and opportunity for communication that there was, you were forced to do that. And I think it was very intentional, and they had experience with that, and they knew that that's what ends up making, these products work out the best. So, anytime, Adam and I sat right next to each other. So, I just go, Adam, what do you think about this? And it's just how it kept going. And, and on top of that too, it's always the scope of work. We always got to come back to the scope of work. What's the plan? What are you trying to do the most with the product? And, sometimes, I think what we find with both engineers and industrial designers is if you're a good one, you're typically very passionate about your project. You're very passionate about trying to get the most out of the product too. I would imagine that almost everyone on this whole panel is here, because we're at, 8:00 on a weeknight doing this, and we want to eke the most out of the product, and sometimes you are faced with the conundrum of we just need good enough, and some products desire a little bit more ID support, some desire a little bit more technical support, and sometimes you kind of have to cast your ego a little bit aside and say, what, sometimes I got to hand it off to the other person a little bit more. As much as I'd like to throw more work, energy, hours, and cost into it. But, a pitfall for a product is spending more time, more energy, more money on it. And then, unfortunately, it never becomes that reality.
Yeah. Next question that we're going to go into, I think this is more probably good for Kat to answer. This is a question just because you work at a place where you are one of the only industrial designers. But Elise asks, how do we communicate the value of design to those who don't want to listen?
Yeah. I also, having come from consultancy land before this, I think that Consultancies also have to prove the value of design in a very tangible way by selling project work, and they put a real number on it. So it's a little bit different being embedded, I think, but I find that I've started to think of myself as a little bit of an ambassador for industrial design, and industrial design has to have like a little bit of a brand. Like people have to know what it is. They have to know what it can do. I'm working with people who it's been a couple of years since they had an industrial designer on the team. So some of the folks I'm collaborating with don't even know what an industrial designer is or does. So I spent probably the first 6 months of my new role doing kind of basic, like I gave a presentation on like what is industrial design, what is human-centered design, what is design research, why do we do all these random things that we do, with the end goal, I think, of eventually having people know the value and hopefully come to me when they have those things. That was something I loved about working with, like at Kaleidoscope, was like if I was on a team with like Grant and he's the engineer, if he sees something and he's like, that's going to violate this design intent, he's going to come talk to me. And so I'm kind of trying to train the whole company up in that way. But I think that by doing that, just like education first and letting people come to me, I almost feel like it's a little bit easier for people to chew on. But you can do that in-house because you're not trying to sell work. I'm there. They already bought me. They have my salary, so they got to pay me. So it's a little bit different, but definitely I see a lot of overlap in the way that work is sold there too.
Mm-hmm. Are there like specific communication habits, rituals, tools, meetings, etc., that have helped like cross-functional teams stay aligned throughout the project lifecycle?
We were talking about roles, and actually I was thinking about RACI charts. I don't know if like you guys have used them before, but I think it stands for like responsible, accountable, consulted, and informed. And you can just take a task and say who's responsible for it, who's accountable for that the task gets completed versus who's actually doing it, who needs to be informed that the task is happening, and who needs to be consulted in the process of the task getting done, which can take a lot of the ego out of the task stuff. So I'm a big fan of RACI charts.
Yeah, another thing. So Kat and I did this on one of our medical device projects. But we had these more like informal, just me and her brainstorm sessions. And those were really helpful for getting the ideas flowing. It wasn't like a sit down formal brainstorm with like 5 people. It's very low pressure. It's just like talking about what we think this product could be. So I think if you can, build that kind of rapport with, if you're a designer with an engineer, that can be really helpful.
Yeah, I think Kristi and Scott sort of touched on this a little bit, and what Grant just touched on too is, it's like sort of treat others how you want to be treated, right? So if like, make sure that you're asking the questions to sort of understand why you're getting pushback, or what is the constraint, or why is design not being, seen as a value add in this instance, right? And so if you further understand that pushback, right, then oh, well, I'm considering that, right? I can consider that when I bring design to the table. So.
Awesome.
Yeah, I might jump in with one other tool, and I think Grant, I love that you mentioned that because I think about the little brainstorms also from like my point of view as like an illustrated conversation, because like my goal is to be able to in the conversation draw what we're talking about, and in the process of drawing it completely align, make sure that I am understanding what you're telling me, that I'm starting to rough out what you're trying to convey about the mechanism or the process or whatever, and hopefully through the process of making like the world's ugliest line sketch we'll end up in total alignment. And I think that just coming to every conversation with a piece of paper and a pencil, and you start drawing when your engineer starts talking, that leads to really good outcomes.
Yeah, and I couldn't agree more with, the setting where you guys can end up kind of huddling together. Like I said, Adam and I sat right next to each other. So, we always had the opportunity to kind of fluently ask one another our opinions and thoughts. And that's where the whys always came out. And I think I always kind of looked at it as like if it was a frequent response of, oh, we can't do this because of this, you have to equally give as much as, well, we can do this in this other way, or we can figure out how to end up kind of incorporating this a concept if we do this, because if you just give a constant pushback and you don't give any kind of flow on how you might be able to accomplish it, even if it's not ideal, then you're just going to look like a person that's just not there ready to collaborate and build.
Yeah.
Yeah, the one other piece I'd add too, I mean, we've talked about communication and then brainstorming is sometimes what I see in a breakdown of communication, right? You're trying to solve something in words and email. But I mean, as designers, we're visual people, but I think most people are visual people. And so, you create a sketch or you take a screen cap and you note on it and you find that you're more easily communicating and somebody else can note on it, right? Use that in email, even if you're not, right, sitting next to each other, right? Just yeah, as a communication tool, I often find myself using that.
Okay. Next question comes from Young Gun. They ask, how do you advocate for user-centered design decisions and conversations that are heavily focused on technical feasibility? What practical suggestions to persuade engineers to accept a design proposal when they say no based on numbers, whether they're about cost or performance metrics?
I had some thoughts on this one. So I think as an engineer, and I think as designers too, we want to meet our requirements. A lot of times in a project, those requirements are a little bit ambiguous and having explicit requirements can really help clear up conversations like this. So the engineers are thinking about their technical requirements, right? It needs to do this, it needs to do that. Whereas the designer is probably more interested in the user's requirements. And so I think having these written down explicitly can be super helpful. And you can point to those requirements and say, if we do that, it's going to hurt our ability to meet this other requirement. The other thing you can do here, it's called a Pugh matrix, P-U-G-H. And this is a great way to actually help people understand why they like or don't like a concept. So if you're comparing two different concepts, maybe one is less usable, but it's also cheaper. You can basically, with rows and columns, document that and say, yeah, concept A is a 5 out of 5 on usability, but it's not very good on cost. It's too expensive. And then you can show that to everyone. Everyone can agree, yes, this is where our concepts lie. And yes, we're still going to choose, whatever concept. We understand that the usability isn't as good. I mean, hopefully that's not the decision you make, but, everyone's at least aligned with, yes, we understand, and we're going to do this anyways.
Yeah, I love Pugh matrices because they kind of quantify the qualitative in a way that helps to facilitate decision making. And I love this term. I picked this up at Mamatome. They call it a swag, which is a scientific wild ass guess. And I love that because it's yeah, my intuition is good. And we can, if you fill in a Pugh matrix with a room full of designers and engineers with lots of experience, then you can actually get pretty good ballparks on how, relatively expensive something will be to produce, or, how long the development timeline is. And I think this really helps to facilitate also, there's an effect, I've heard it called the hippo effect. I think it stands for the highest paid person's opinion. And the idea that sometimes in rooms, the decisions that are made are not actually about how good or bad the thing is at all. So keeping it a little bit not so subjective, a little bit more objective. We put it in a chart. You can't really argue with numbers. Yeah, I also like to, if I do usability testing or a heuristic evaluation or any kind of test, I really want to take those outcomes and make sure that those are really clearly communicated. I think that can be really helpful also with if I have evidence from the users and I've laid it out clearly enough that they prefer a certain direction, hopefully that's something that, my teams aren't going to argue with. The users are pretty clear and we'll go forward with that decision.
Yeah, in addition to maybe using kind of the Pugh matrix and such in order to try and push an initiative too is we've also used like pairwise comparisons too, a lot as another tool, just because I feel like a lot of times when I kind of bring back to the team, you always are plastering up on a board all of your requirements and all your ideal situations. And, I know as engineers, and I'm sure industrial designers too, we always talk about the holy trinity of engineering, your cost, speed, and quality, and you can only have two and not three. You're always trying to balance out your trade-offs and what seems to be most important, and it kind of helps you gain during that product realization process of what is the ideal user need and outcome that you're looking for. So that pairwise comparison gives you that hierarchy of what beats out what when you come to a decision making opportunity, and how do you leverage that. And it's meant to be living too. There's many iterations of prototyping and development for that very reason, and that's where it's important. Industrial designers are very talented when it comes to having focus groups and supporting usability studies and such to help try to prove those outcomes. That just kind of further validates what you're looking at when it comes to that outcome. But even kind of tying back to the question here that was talking about how do you advocate for user-centered design, kind of taking a little bit of a tangent here. Something that I try to remind any entrepreneurs that we're working with or physicians or whoever is that they're consumer too. And, how do you end up going into, and this especially works when it comes to engineers, is when you go to Home Depot, how do you choose what power tool you're going to buy? Or how do you choose what car you're going to buy? And they start to quickly realize how much they're influenced by how that product was developed and the beauty behind it, the user experience behind it. And I mean, I think a lot of us have been able to go into a Home Depot and, grab a brand new, screwdriver, pick it up. And even if you didn't know it was a brand new model or something, you can immediately become familiar with it. And you immediately understand how the system works without having any kind of instructions or documentation there. They're very inquisitive when it comes to making people not feel intimidated by the product, but then just understanding it. And, product development has become so good today. And there's so many little details now when it comes to products where it's not just always about being technically proficient with it. Sometimes it's just about making something that looks good and feels good and does the job. And it's what's going to beat out your decision making and the branding and so forth. Ryobi was brilliant by making their brand color literally fluorescent. You can't miss it in a hallway. So sorry for the tangent, but wanted to go back to that.
That is such a good piece of advice. I'm putting that in my pocket for, to the value of design. Yes, absolutely. That's it. People understand that analogy so clearly. And I'm stealing that.
You may.
Yeah. And to add to it too, it's like we all do want the same thing. We all want this product to be successful.
Yeah.
So with what you're saying, Ian, like if you can incorporate those aspects, it has better odds of being successful, which is the whole point.
Mm-hmm.
Yeah. So I know Carly just had an issue with her Wi-Fi, so she's jumping back on with a hotspot. But in the meantime, I have the rest of the questions pulled up, so I'll just ask our next one. Mache asks, what are common grounds which can be leveraged to enable better teaming between designers and engineers? What digital or analog tools are commonly used in both design and engineering workflows?
Yeah, I mean, for me, when I'm working with a designer, we're sketching a lot, just hand sketches. Theirs are going to look a lot better than mine, but that's kind of like a way to communicate. SolidWorks is definitely a common tool. It's how if I'm having trouble drawing something, I'll probably go to SolidWorks to demonstrate that. But yeah, I would say those are two tools, if you consider drawing a tool, that definitely help with those communications.
Mm-hmm. Yeah, I would pretty much echo that. I mean, like I mentioned before, sharing common tools. And so sketching, I think anybody can sketch, start there to create that image rather than through words. But then SolidWorks, um, and what I've tried to do throughout my career too is just, there's best practices around SolidWorks so that when you're handing off that SolidWorks model or not, sorry, I'm using handing off, but if multiple team members need to touch that SolidWorks model, right? Um, that when, as a designer, it's going to an engineer, they're not rebuilding it, right? You are building that model in such a way that it becomes a communication tool, um, and right, and you're building in the design direction, but ideally, right, when they're starting to build in the technical pieces, adding the board, the screen, um, that they can grow and expand. And then if it comes to it, right, they're going to then, because it's your model, and they're like, I was comfortable just getting into your model and evolving it. Um, they'll come to you when they feel like, oh, I'm pushing too far from what you handed over to me.
I like to use Miro to keep my work. Sorry to beat you to
Beat me
it.
to it.
You might have a different, I'll let you go first because you might have a different reason than me. So I'm kind of curious now.
No, I was just going to convey, I had no clue what those were until I started working at Design Central. A couple places I worked at before Design Central, they didn't have as much industrial design influence as some of the other companies I've worked with recently. But yeah, I mean, a Miro board was outstanding because, I think as soon as you immediately start, you're constantly looking for inspiration. And I'd never seen like an inspiration board before, quite like what Design Central had done. And I know I've had a past of actually being around Kaleidoscope too. And I realized like, okay, you guys might look for inspiration from, what brand language might look like and what the product could look like. But one of the people on the early panels, like, if you're certainly an engineering consultant and you're being pulled every which way and all these different design concepts, you have no clue what you're getting into sometimes. You could be pulled into something that's completely new and brand different. And so I always go back to just reverse engineering and just start figuring out like, let's not reinvent the wheel. Let's look at what works well and what concepts have worked out outstanding. And there are an incredible number of resources that are out there that you can find online that, have some great references on some different, mechanical linkages, mechanical designs. I know I've spent, sometimes I'm flipping through YouTube and all of a sudden I'm randomly watching this video of like 10 different random mechanical linkages that are all just being animated in a row. I'm like, how the heck did I get here? But I'll start screenshotting and take those ideas and concepts there. And that was an amazing way to organize out some thoughts.
Yeah. Yeah. One of the things I like to use it for is like, I think to like sort of basically create what you're talking about is like a place for like the design work to live and be interacted with and be seen and be like in a living space for the whole team to collaborate. Because I feel like especially now, like if I don't show what I'm doing, my work exists in like 10 folders deep in a place that nobody but me knows. Nobody's going to be able to see what I'm doing or understand the progress I'm making or why it matters. So I, have Miro boards for all the projects that I work on, and I just put everything that I do on there. And yeah, it like lives on a nice drive somewhere also. But that way people can just jump on the Miro board and then they can sort of see the whole rough process. And it's not my nice documented process book. It's just sort of a working space. But I think that's done a lot for like adding that transparency. And then I'll also give a shout out for like meeting the engineers where they are. Like something I've learned, and this came up earlier with like medical device design, is that like requirements are so important and the FDA design process is really thorough. And I've found that sometimes like it behooves me to get involved in the requirements generation process and get into JAMA and start writing requirements and working with my human factors engineer, my systems engineer directly to influence that, because I have very strong opinions on what the users should get out of the equation. So if I can make a requirement for my user needs up front, then the engineers and I have the same goal, which is like, that's the dream come true, where we've made my design usability needs a requirement, and then we're all sort of aligned and, agree that that's equally important. So that being said, it's not the most exhilarating or thrilling work I've done as a designer, but it does pay off big time.
Yeah, I think Miro and Mural, they're both very similar, but I think those are both like really great like visual um ways to organize visual content as compared to like doing stuff in Word or any other like in the file server where stuff can get lost. Um
But
But
I'd like to there was one chat, the 3D prints. I mean, I'd actually say now with yeah, I mean that we have 3D printers, on hand, you can just send whatever. Like that does become a communication tool, and we find ourselves using that more and more. I mean, um, the Design Central, we all often get called the 3D people. And it's because we get into 3D, meaning, something physical you can put your hands on early on. And, traditionally it's been, hand models, but now, right, you get a 3D print in an engineer's hand or a client's hand.
awesome. So I'm going to ask, we have like 4 more minutes here. I'm going to ask one question from Brian. So I'm skipping ahead just a little bit, but Brian wants to know what everyone's experience is with doing final DFM CAD. Like when should an ID person do it versus when should an engineering person do it? DFM being designed for manufacturing.
Ooh, that's a good question.
Mhm.
I like to be in charge of the final form, like the outer body, and then I would like to deliver a solid body to the engineering team that has been developed with full understanding of all the components that are going to go in it. But then the engineers are responsible for what happens on the inside, the shelling, the supports, the mechanism, all of that side of things. But I own that outer surface. That's an ideal world, but sometimes the mechanism ends up on the outside a little bit, so you do what you can.
Mhm. Yeah, like I mentioned, and I think Scott mentioned this too, right? I'm blurring the lines with engineering more and more. And so like even when we get to part breakup and you need to start considering things like draft because you want to put a texture across the surface, it's like you had this perfectly beautiful curve in your sketch, right? It's perfectly rounded. Well, I got to run a part line through there now. Now I draft on both sides. And so I I think as long as, I'm finding that choices that are DFM are impacting, the exterior in some way, and at that level of like incorporating draft or adding bosses that might grow the bezel right around the screen, or we can only have so much opening for the board, or the board can be, there's limitations that can come up. But if it is impacting the exterior and sort of or the user experience exterior of the product in any way. Yeah, I don't mind being involved in sort of championing the CAD further along. Yeah. But it's blurry too. I mean, with smaller teams, the other thing I find is um, if we have more engineering work, then I can sort of take some of that engineering work. But if we have more design work, then we might be handing off a design sooner to the engineering team. So
Mhm.
developing yourself to be more versatile, even in smaller teams, right? Then you can take on the work that you have at that time, right?
Yeah, I would say, oh, we're almost out of time, but yeah, typically I would expect an engineer to do the final DFM push, but with industrial design input, right? They can't change any part of the experience or the exterior without consulting industrial design, would be my take.
Mhm. Yeah, and
Yeah.
that solid model that I'm talking about, like this is something that like in my career has never been like by that point, it has been handed back and forth between design and engineering like 5 or 6 times minimum. And so it's like, yeah, maybe I'm doing the final surface CAD that I then give to them and they shell it. But that surface CAD couldn't exist without exactly what like Adam is describing, like all of those conversations and trade-offs that are happening, like what mechanism needs to go where, what the part breaks are doing, what the different materials, is this going to be double shot, how are they going to be assembled? All that stuff has hopefully been considered before that nice final shiny version gets shared.
Yeah. Yeah, and a lot of it can end up kind of going in tandem too. I've kind of done, kind of the same as like Caterina was saying, like I've just gotten a solid model and just kind of started from there, started shelling, adding ribs and so forth. But sometimes I might be kind of working in parallel with the designer where I might already know a lot of what the internal mechanisms and features and assembly items might be within there. So I might be building from the inside out, just laying out where those might be, and then just constantly checking on, okay, what is the designer throwing in within their concept to make sure I could still kind of fit each and every one of those constituents in there, and then just kind of build out from there.
Awesome. Thank you, guys. I'm going to go ahead and pass it off again to Dwight so we can get into our Q&A section. Yeah, so thank you all four of you guys for being on this panel and taking the time.
Thank you so much, Carly. I'm going to leave everyone up so I don't have to unpin you and repin you again.
Am I visible and legible? Perfect.
Yeah, you're
thanks,
real.
Kat, Grant, Ian, Adam, and Carly. Finally, it's time to bring together everything we've learned and tie our skills, or the skills that we've learned and the communication insights together. We'd like to bring back all of our speakers from the first two panels to answer some of the questions you've shared with us ahead of the event, as well as some questions that you've been sending us in the chat. Now we'll be hearing from our panel of professionals about how you can use the tools we've shared today to grow your career. Whether you're navigating the handoff between design, development, co-creating with engineers from day one, or simply looking to deepen your technical fluency, we hope this Q&A session will get you the answers you need to take this next step in your ID career. Let's welcome all our speakers back to the stage: Maria, Kat, Kristi, Scott, Grant, Adam, and Ian.
All right. Hello, everybody. My name is Maria Vasili. Thank you guys so much for joining us. I'm an industrial designer in Columbus with Design Central, and I'm the chair of the IDSA Columbus chapter. So we've just heard from our wonderful panelists about some methods that they use to collaborate more efficiently with engineers and engineers with designers. And so now we want to give all of our speakers a chance to come back and answer any more of your questions about design and engineering. If you have any additional questions, feel free to drop them in the chat, and I'll keep monitoring that as we go. Without further ado, I would like to welcome our panelists back to the stage. Thank you, guys. So starting off with a question from Joshua. What do engineers want to know about industrial designers, and how do we fit into your process?
Yeah, I think ultimately we want to know what value you bring to the conversation and to the table. As Kat was saying earlier, not all engineers know what industrial design even is. We hear design and we might think, oh, they're just making it look pretty, but it's obviously so much more than that. So I think, communicating what you do and your value there, and then kind of, telling us how do we work with you? What does it look like? It's collaborative, obviously, but engineers might not know that. So helping them understand kind of what an ideal workflow could look like, I think, is totally valid.
Yeah, I think another thing to kind of add on that too is I think it's a very common thing for when people get excited about their product that they want to kind of champion everything about it and, take it all the way down to production. And I think you very quickly learn as you end up really starting to become a deeper industrial designer or engineer that you can't fulfill everything. Or if you want to get the best out of the product, you have to have multiple people that are all within the process. And, the best teams are the people that have completely different skill sets and completely different mindsets and pasts and experiences on how you end up pushing that project. And the more you start to realize that and kind of humble yourself along the process, you realize that you really need those other people that have those other skill sets, that just help embrace your own skills. You could focus on those and not try to, be everything else that you might not be.
Yeah, totally. All right, next question. Have any of you guys seen examples where engineers also took steps to learn design fluency? What did that look like, and how did it affect your collaboration?
I can jump in here. I've always found it extremely helpful when engineers draw. Like, I don't care what your sketch looks like. I'm not judging it anything like the same kind of standards or consideration that I'm judging an industrial design sketch because you're not an industrial designer. But it helps me so much to understand your ideas. And I think it's really easy to feel shy or overwhelmed in a meeting when an industrial designer is drawing and you're like sitting there looking at that and it's, there's a lot of pressure to draw. But I appreciate the engineers who are willing to do it anyway. And I've found that like there's a an industrial designer at Kaleidoscope, Tom Granetsky, and one thing I love that he does is he teaches sketching to the engineers and like doesn't just assume they'll pick it up. He actually teaches them like intro industrial design sketching skills, and I think I've seen that just do so much for confidence building. So if there's an engineer that you collaborate with closely and they have any interest in sketching, like I would say don't be shy to share some of your, sketching and illustration skills and help like equip them to be a visual communicator too, knowing that it's your job to take their idea to the next level, but it sure helps if you can get an idea of that idea a little quicker.
Another thing too
Yeah,
that
go ahead.
is done. Oh, go ahead, Scott.
No, I would just say, and just being, I think it's really helpful to be open to what the engineers are saying. Like the idea of just like the best idea in the room wins, and like sometimes engineers have good ideas about how things should work or how things should look, and just being really open to that, I think helps encourage more open collaboration, and it helps help the reciprocal of them being open to you.
Yeah, and I think, a lot of times at Kaleidoscope, we'll have boards that show all the different concepts or brainstorm sketches. So I think that's helpful for engineers to see, okay, this is what the industrial designers are creating. They're considering all these different concepts and factors. Just exposure to that, I think, can help a lot too.
Yeah, and I think this was mentioned earlier, but just never stop learning. And so if you are helping to foster environments at work, almost similar to um, the environments back in school, right? Where it's just as a designer, we're continuing to learn about materials and processes. But I mean, engineers, right, hopefully would feel comfortable in that same space, learning why we value, the user experience and what that means to translate into design. You know.
And I may have mentioned earlier, part of, understanding how much, industrial designer might influence, your work as an engineer. One of the best ways to really start to understand the value of them is if you start trying to do what they do. And, you start to realize how complicated that can be and how much more versatile they might be within their position. And, learning that kind of design fluency is not necessarily to negate their necessity. It's more to kind of grow your interest in it, gain respect for it. But then also, God forbid, what if they're not there and, or maybe they weren't worked within your product or project. And, maybe you have to start to try and fulfill that a little bit yourself. Just makes it more fun.
All right. Next up, Kazia in her registration asked, what are the best ways to navigate the leadership conversation challenges surrounding what falls to engineering versus designers in a project?
Adam, I don't want to put you on the spot, but I'm really interested what you have to say to this one. It's like as someone who can do it both, how do you figure out like if you do have to assign work, where's that line for other people? Do you always know?
It's a hard one.
What? Sorry, give me that question one more time, Maria. I think I
Okay.
zoomed out for a second again.
So, what are the best ways to navigate the leadership conversation challenges surrounding what falls to engineering versus designers?
Mhm. Yeah, it just yeah, it becomes so blurry. Yeah, you put me on the spot, Kat. But
Sorry.
I don't because I find myself in such a role where I'm taking on both. And I think at Design Central we've sort of said like if we can create industrial designers who sort of can blur those lines more, um, then we become a more versatile team. But um Yeah, but as you develop those skills, I think this was also mentioned. I mean, we need to keep bringing in design and blue sky thinking. Um, so I don't know if that quite answers the question, but yeah.
I, something I feel like is there are definitely things industrial designers shouldn't do, that
Mm,
we are not like educated or equipped to. Like, like I shouldn't be the person who's like actually writing the documentation that goes to the FDA. Just that's not, I'm not trained for that. That's not my job. It's really best if I'm not the person doing that. I just think there's all sorts of things that like industrial designers are great jack of all trades, but like I don't think that like if you would like what we were saying about the like final DFM build, you just don't want an industrial designer owning that. And like there are some things where it's really appropriate and everyone I think has a better time if like those roles are really like clearly outlined from the start. And that way everyone is playing in their own swim lane and there's none of that like the blurriness is at least established like from the beginning. And so far as like, yeah, sometimes I might step in and do things that an engineer can do, but that's going to be established from the beginning and it's going to have a clear limit and say like, okay, well, I'm not going to be the final reviewer to sign off on something, but I might draft something for them.
mhm.
So yeah, I
No, that's super fair. Yeah, because yeah, you want to blur lines and have a general understanding, but you're right. We're like we also have a capacity as people, and so um, yeah, I'll I'll leave that at that.
All right, we have a question from Jackie in the chat. I think we touched on this a little bit earlier, but we can bring it back up now that we have more people in the conversation. So she said, how can we as designers show the value of our work to engineers? Sometimes I feel like design work gets under prioritized over engineering work.
I wouldn't mind jumping in on this one. This is a good one because I was actually kind of excited to be able to talk about this topic a little bit. I think maybe one of the best examples is like say someone were design they want to design an open-ended crescent wrench, something real simple, looks like an IKEA like laser cut out of sheet metal crescent wrench. And they're saying, yeah, we got to make this thing 10 cents. We got to make millions of them. We got to make them as cheap as possible. And the industrial designer just keeps getting kicked down the curb because they're like, oh, why do we need that person? We're just making another thing. We're making this as cheap as possible. But where it can be really effective to end up being able to blur those lines and for that industrial designer to know manufacturing, the engineering, they can come back in and go, well, yeah, what we're really paying for here is machine runtime, right? That's not a person, that's not labor. As long as I try to, still keep it that one manufacturing step, then there might be things that I can incorporate. So then they start to realize, well, what if I add into that CNC cut pathway some scallops that are in there that can then have, a gripping area for your fingers and can hold it there. But then you start to look at it and you realize, oh, at the other end of that crescent wrench, normally it's just sitting there blunt. What else could I do there? I could put I don't know, a bottle cap and opener over there. I could put a flat or a pry bar on there, or something for a screwdriver. Something I try to remind, some of my students, we talked about tools earlier. A really, really great one. I think a line that all of us, the two of us can blur with is business development and marketing and so forth too. And sometimes we have to look at those tools. And one of my favorite tools I learned about not too long ago is the Kano model. And the Kano model does a really great job at representing what are basic needs versus performance metrics versus delighters. And a product, if you don't meet the basic needs, so say like a car, for instance, if you don't have brakes in it, then people are going to be pretty furious about that. But if you do have brakes on a car, they're going to go like, oh yeah, that's what a car's supposed to have. But you have performance metrics like how fast it can go and how much MPGs you can get out of the car. Those are things that you're just linearly going to scale over time. But then you have delighters, and there are things that you could pepper into a product that they're not expecting to, but if you do, it just makes it all the better. And sometimes when you're weighing in whether or not if a feature may be desirable or not, in this instance for a crescent wrench, why is it not worth me adding one of those extra features on the back of it? It cost me no extra money. It didn't change the machine runtime. And all it did was just make that person smile when they pick it up and use it.
Yeah, I like those. I feel like I call them like free features that you can add, like things that can improve the experience without adding any cost or changing the manufacturing process. Or like maybe I'm not going to get you to add an overmold, but I can maybe change something about the existing texture for free.
Right. Right. And even if they might not go after something like a design feature, then, oh, let's talk about brand language. You know, okay, how do I incorporate your branding in there? How do I incorporate this in there? It's not just, you know, features and making it beautiful. It's, you know, sometimes about keeping them focused on how do they remember you when they look at your product again.
Great answer. Thanks for that, guys. So next question. What is one thing that you wish engineers understood better about industrial design and vice versa, when it comes to communication and collaboration?
Maybe I feel like the assumption that industrial designers already know that it's not possible and want to make it anyway. I think usually the assumption is really on our end that it is possible, or we're not really like thinking about it like that, or just coming at it from a different direction. And so I think it's rarely does it come out of a place of like, I'm just trying to make like my engineer's life more difficult. It's more out of like, oh, I think this would be really fabulous. And I need an engineer to remind me of these realities so that I can kind of keep things on the rails. And I always really appreciate like, I don't know, just circling back to the you catch more flies with honey than with vinegar. I think when those reminders are delivered kindly and gently, I think that that helps and makes a really good collaboration.
One thing I would say is just if, I guess if an engineer sees something as more of like a personal opinion or like a personal preference, like, oh, I just like things that are like, you know, just a little bit more square or something versus having some, you know, research behind it or, you know, some logic behind it. And I think that, you know, falls a little bit back on the designer to explain themselves and, you know, not just kind of come out of nowhere. Like other people have talked about, you know, having the sketches up on the wall and the mural board of research, you know, I think can go far towards preventing that. But I think that, you know, that can be a pet peeve of, you know, and I think that, you know, that's not just for engineers, it's also like, you know, management, you know, who says, oh, well, I have favorite colors too, you know, that sort of thing. Like, so it's just, you know, not understanding that there are, real reasons behind design choices.
Yeah, I think engineers, I can at least speak for myself. Like, I want designers to know that I'm constrained in many ways, right? Like, I'm constrained by cost, I'm constrained by manufacturing methods. So I'm constantly thinking about all those things when I'm trying to come up with solutions. And like, you might come up with something that I don't think is possible. But I think there's still a lot of value in that because that can get me thinking, okay, you know, doing it exactly like that, I can't come up with a way to do that. But, you know, what about this? So I think there's a lot of value in that. And I guess I wish more engineers knew or had that appreciation for, even though the sketch as it is impossible, there's still a lot of value in it because we might be able to tweak it and make it work.
When you just said that sentence, I can't do it that way, but what about this? That is like my favorite thing to hear when I'm collaborating because it's like, yes, beautiful. I don't know what I don't know. So yeah, help me get there.
Yeah, I love working with engineers who are open to exploring ideas that they might not think are possible, but like trying to find some way to make it work in the middle. It's always a lot of fun. All right. Kind of going back to a conversation that we were having earlier in terms of like softwares that designers use versus engineers use. Kazia had asked in the chat, how do you best navigate the software rift between Creo and SolidWorks without on-site engineers?
Maybe can we do a quick show of hands on like who uses maybe SolidWorks or Creo?
Yeah, who uses SolidWorks? Raise your hand. Who uses Creo?
Okay. I felt
Yeah, I think
unequipped to
Theo is
answer that.
cars.
So it looks like we have some folks in the chat though who use both, and then some folks who use Fusion as well, which I think is really common for students.
Yeah, I have found that SolidWorks in recent years has gotten better about working with non-native data. Like you can throw now in assemblies not a SolidWorks part, and it's not going to try to reinterpret it for SolidWorks. It just like loads in the geometry. You can just have a Creo part, or you just like a step file just existing in your assembly. So in that way, it makes things a lot easier because you don't have to translate back and forth, at least on a component level. For surfaces, that becomes a whole another thing, because you can't obviously export a surface in just like a dumb body, and then somebody can build off of that. And sometimes people do that, going from like a Rhino surface or something. I know, but that becomes a lot messier because changes are still really tough in that instance. You can re-import the body, but then you're spending an hour or sometimes a lot more fixing all your mates and all your references.
Yeah, I think our team works pretty much exclusively in SolidWorks at this point. So, it can be passed back and forth between design and engineering as much as you need to, without having to convert files. Because like you said, Scott, once you convert files, it's time wasted.
Feature recognition is a lot. Just want to throw that out there. I've never in my whole life seen feature recognition actually do anything useful. Mic drop. That's it. That's all there is. Yeah. It sounds like some folks in the chat though also use NX. And maybe in like defense work as well. And I know like Alias, sometimes like we use that sometimes at Kaleidoscope when we were modeling like organs or something very like organic and fluid that was like, okay, yeah, you try modeling intestines in SolidWorks. That's very fun. It's a little easier in Alias. But that does get exported. There's no, it's dead at that point. You can't change it.
All right. Moving on to our next question. I'll just ask one more question because it seems like we only have a few minutes left before we need to wrap up. But Samuel asked, he said that he's on an engineering team currently, and I'm wondering how I can further apply and communicate industrial design skills to help the engineers make more ergonomic and human-centric design. That might be a good question for Kat, who's currently on an engineering team.
It's a nice question to end on too. I would say if you, so I don't know if Samuel is an engineer or an industrial designer, but I think either way, knowing a couple of principles behind like human-centered design and like maybe even just looking at like driving requirements around usability, I think that like using some of those like more tangible metrics are the ones that are easy to convince people of. So like I have this one paper that I'm just obsessed with. It's like a usability heuristics for medical devices. I'll post a link in the chat, and it's basically a guide on how to run a heuristic evaluation for a physical med device hardware. And like I love using that tool, and like that's something I would always recommend to engineers to say like you could probably run this activity on your own without an industrial designer, and it would end up with a lot of the same usability insights that we're going to glean through our design intuition, but it's a little more systematic of a process. So I think that things like that are like like a crisp handoff, like an activity or like a process that can be done, those are really easy to kind of self-start. I think even like at Kaleidoscope, we made a brainstorm kit so that, like originally you had to get an industrial designer to run your brainstorm because they knew how to organize it. And eventually we put together like a box that had all the things you need and a little guide on how to organize the schedule and how to have your prompts be effective and all that good stuff. So I kind of like the plug and play tricks.
Anyone else have any thoughts on that question before we wrap things up?
I guess I would just say don't let things lie too much. Like I feel like it's tempting to uh, like approach things friendly, but like if they're messing with your surfaces and you're just like, ah, come on, just talk about like what is curvature continuity and why do I care that's the surface can't just be throw a tangent fill it on it. It like seems like nitpicky, like just a little bit of kind education goes a long way. I mean, I guess that's not into the the user-centered design and usability portion of it, but I think just the educate. We've talked about a lot about designers learning engineering skills, and I think it's I think Kat has talked a lot about the education going the other way and just doing it kindly goes a long way.
Great. Any final thoughts before we wrap up and I hand things back to Kat? All right. Thank you guys so much. This was such a great session. I learned a lot. I hope everyone else learned a lot. And now we'll just pass it back to Kat to do some wrap up.
All right, thank you. Let me slowly unpin everybody one by one. Wonderful. Well, thank you guys so much for joining us for this really fabulous event. I don't know about you, but I really enjoyed these conversations with our panelists, and it was so great to have so much conversation and engagement happening in the chat. Really appreciate all of you for making this such a lively event. So again, really appreciate the time from all of our panelists for joining, to our fabulous volunteer teams from IDSA, Cincinnati, Cleveland, and Columbus. Thank you for all of your hard work in our fifth installment of Blurred Lines. We hope we'll see you again next year for our next Blurred Lines event. If you have any lines that you want to blur, feel free to drop those in the chat. We will be posting a recording of this session on the IDSA Cincinnati YouTube page, and we'll share that link out with everybody who attended. And we will also be putting together a resource one-pager, all the links that everyone shared in the chat, all of the resources that our speakers and panelists have gathered throughout their time prepping for this event. We're going to put all of that together for you guys to take home. So we'll share that out in the next week or two. Awesome. So thank you everybody so much and have a great night. We'll see you next time.